Analysis of algorithm. In computer science, the analysis of algorithm is the process of finding the computational complexity of algorithms. That is, the amount of time, storage, or other resources need to execute them. I again repeat, the amount of time, storage, or other resources need to execute them. Usually, this involves determining a function that relates the length of an algorithm input to the number of steps it takes, called time complexity, or the number of storage locations it uses, called space complexity. When we talk about data structures and algorithms, we talk about two things, and that is what would be the space this data would require to store, and what time it would take when we make this computation from this data. When we talk of time taken by this algorithm, we said it is time complexity, and it is defined as the length of an algorithm input to the number of steps it takes. That is, these are the number of steps. It will take 5 number of steps or 10 number of steps to perform this function on this data. When we talk space complexity, this number of space it will be used to compute this data. That is called space complexity. An algorithm is said to be efficient when this function's values are small or grow slowly compared to a growth in the size of the input. Different inputs of the same length may cause the algorithm to have different behaviors. So we can say best, worst, and average case of complexity. This description might be of practical interest. Usually when we talk of analysis of algorithm, we put our focus on the worst complexity. Second thing, we talk less about the space complexity in comparison to time. Why? Since today's hardest RAM, the caches are cheaper nowadays. So we don't talk much about the space complexity. So what our focus is that time. The time should be constantly less for a particular set of data. So when we talk analysis of algorithm, we say worst time complexity. Big O notation. Big O notation is a mathematical function which is used to compute this. Algorithmic complexity is commonly represented by the OF notation, also known as asymptotic notation or Big O notation, where f is the function of the size of the input data. The asymptotic computational complexity OF measures the order of the consumed resources, that is CPU time or memory, etc., by certain algorithms expressed as functions of the input data size. When talking of complexity, we majorly talk about the time complexity in worst case. This we need to remember always. Now, what does this big O notation mean? And what is this OF function notation means? We have some input, let's say for any value c, where k dot f of n is equal to running time, where c is greater than or equal to 0, and running time complexity for x greater than or equal to c is always less than k dot f of n. So O of n is equal to k dot f of n for all x greater than or equal to c. What does it mean? Here I have x-axis where I have the inputs from 0 to n, and here is this number c. On y-axis I have the running time complexity. So I have a function that is k dot fn, which is always above this running time complexity for each value of x greater than or equal to value of c. Any x which will lie in this area, this running time is always less than this graph. So if we have this O of fn, if we have this big O notation, then we can say that its running time maximum would be equal to this O of fn, else it would be always less than that. So this is called big O notation. Now there are different type of algorithms where different type of time complexities will come into picture. First I will consider linear search. What does this linear search means? I will talk about that. But when I will say this is a linear search, the picture that gets clear to you that it will take time complexity of O of n. That is, for each value of x, the same value of y would get increase. What O of n means to me as a developer, what this O of n means to me. Let's say I have n students in class and I go to each student. I will go, the teacher or proctor will go to each student and ask their name to search for any student like Arun. I have n students, so in worst case, I have to ask n students whether you are Arun or not. So this is called linear. When it comes to development, when it comes to Java programming, there is a for loop where you will have I is equal to 0 and I is less than equal to n. That is maximum values n. You have a big O notation of n. Binary search. Binary search has a complexity of log n. What does it mean to me? Let's say I have a class of students from height 5 feet to 6 feet and I need to find student of height 5.7 feet. If I go to each student, then the computation would be linear. That is, I am asking to each student, what is your height? So, this is not answer. In binary search, what I will do, I will divide whole class into two groups. Initially, one from 5 to 5.5 and another from 5.5 to 6 feet. I will divide the whole class into two groups. Now, I am searching for 5.7. So definitely my 5.7 cannot lie between 5 to 5.5. So I will discard that half group completely. And now I will search from 5.5 to 6 feet. Now again I will divide, that is 5.5 to 5.75 and from 5.75 to 6 feet. So whenever I am discarding a half group and analyzing only the other half, that means I am in a complexity of log n, and that is called binary search. I again repeat, I have n students and I am searching for a 5.7 height within the height of 5.5 to 6.5 or 6 feet. I have divided that group from 5 feet to 5.5 and 5.5 to 6. My 5.7 would lie in the another half, so I am discarding the half directly. That means each time I am iterating and discarding the half of the group, so my complexity is log n. I am not talking to each student of the class. Example is binary search. Polynomial algorithm. Polynomial algorithm have big O notation of n raised to the power c. This c depends on the polynomial function. If it is binomial, this c would be 2. For trinomial, this c would be 3. If I said O is equal to n raised to the power 2, so example would be bubble sort, selection sort, insertion sort, bucket sort. What does it mean? To find a student with name Arun Singh, we reach to each student and then send this each student to all other students whether they can identify Arun Singh or not. I again repeat, here the teacher is not going to each student. I am asking the first student, you go to that n-1 student. Then I'm asking to second student, now you go to that n-2 students. I'm asking third student, now you go to that n-3 student. That means each student is talking to the other students of the class. What does that mean to a developer? Programmatically, I have 4 int I is equal to 0, I less than n, I plus plus, and 4 int j is equal to 0, j less than n, j plus plus. So the complexity would be this, they are two for loops, that is n cross n square. For bubble sort, selection sort, insertion sort, and bucket sort, my complexity is n square. superlinear algorithm, that is n cross log n. Example here is heap sort or merge sort. It takes n cross log n steps for performing a given operation on n elements. I will deeply explain heap sort and merge sort in my future video. Let's move further. Comparison. What is best for me? If I can have O1, that is, I can directly access an element, like I can access from array. Array, go to position 2 and find that element. So that is the best case. Linear search. I'm running through the n number of elements and getting my number. That is second rank. Binary search, that is third in rank. Analog n, that is heap sort or merge sort, that is fourth in rank. N square, that is 2 for loop, that is worst case. Let's have complexity measure. For now, you can just remember this. I will explain each time the complexity of each algorithm that I will talk about. For array, access is O1, search is On because you have to search with all the elements. Insertion is On, deletion is On. Space complexity is On for every pair. Stack access is On. If I have to access third element of the stack, I have to remove 2 elements out. If I have to search for third element, I have to search through all the elements of the stack. Insertion, you can just go and push at the top. Deletion, you can just pop from the top or remove from the top. Queue, access, you have to access all the elements of the queue. Search, access to all the elements and then only you can search. Insertion, just go and insert an element into queue. Deletion, remove the element from the head of the queue. Singly linked list, access, On. If I have to read any element, I have to read all the elements of the linked list. Search, again I have to search all the elements of the linked list and then I will say this is the C. Insertion, just go and add a node, it is O1. Delete, go and remove a node, simple. Double linked list, same. Hash table. Basically for hash table you cannot find a complexity of access. Sometimes you can say On, but it depends on the hash function. Search, it is On because you have to access to all the elements of the hash table. Insertion, again On, and deletion, again On. Binary search tree. If you have to access elements, you have to access all the elements of the tree. If you have to search, then again search through all the elements of the tree. Insertion, again On, and deletion, again On. This is not a sorted binary search tree. This can be incomplete binary search tree also. Now we are talking about B tree, red black tree or AVL tree, whose access time, search time, insertion and deletion all are log n. If I am saying log n, so definitely I am discarding the half and focusing on the half each time. Complexity of sorting algorithms. Let's talk about time complexity. If you will talk about space complexity, there are also again different. Let's talk first about quick sort. Time complexity is O of n square, that is n square, n cross n. Space complexity is log n. Why space complexity is log n? Because you are discarding half of the elements in one way. Merge sort. Time complexity is n log n. In terms of time complexity, merge sort is better than quick sort. But in terms of space complexity, merge sort is poor than quick sort because log n is better than n. Let's talk about heap sort. Its time complexity is same as merge sort. but space complexity of heap sort is O of 1. When we compare quicksort, merge sort and heap sort, time complexity of quicksort is worse. So these two are good in time complexity. When it comes to space complexity of heap sort is best. O of 1 is best. So I can say in terms of quicksort, merge sort and heap sort would be the best case for sorting. Why? Time complexity is and space complexity both are in best. Now let's come to bubble sort, insertion sort and selection sort. As you know, they will take n cross n, so complexity is n square. Similarly for bucket sort, it is n square. For space complexity, this is O1, but space complexity of bucket sort is On. Radix sort, O of nk. Counting sort, n plus k. Cube sort, n log n. Space complexity O of n plus k. Counting sort O of k. Cube sort O of n. Now let's compare whole this graph and see whether heap sort is best or not. N log n, if you will see here, n plus k would be better than n log n, because n plus k would be n or 2n or 3n. In that case, counting sort in some cases could be better than heap sort, but not always. Now talk of space complexity, it is O1 and it is OK. So only counting sort and heap sort are comparable. But if this k goes very large, then heap sort would be the better choice. So in general, we used to say heap sort is a better choice. Thanks.